All right, so for week 6, we're going to discuss introduction to time response and different types of test signals for LTI or linear time invariant systems. So we have here an introduction to LTI systems. Let's say consider a system G and any two input signal x sub 1, x sub 2, such that y sub 1 is equal to gx1 and y sub 2 is equal to gx2. System G is said to be linear if x is equal to ax1 plus bx2. AB is an element of C, wherein y is equal to gx is equal to ay1 plus by2, wherein it is called the linear superposition. So medyo nakakalito itong unang part na to, but let's clarify that later on as we progress with the topic. So now suppose that y of t is equal to gx of t. The system G is said to be time invariant if for any t that is equal to y multiplied to the quantity yung maliit na t minus malaking t, which is equal to gx multiplied to the same quantity of t. In other words, if we time shift the input signal by t, then the output signal can simply be the output original signal time shifted by t. The LTI is uniquely represented by its impulse response, wherein the class of LTI system has a very rich theory and a broad range of applications in engineering. The impulse response system H is simply because it is the response to a unit impulse shown in the diagram below. So that is true. Feedback and control system doesn't stop here as you take the subject. Yan po ay maraming application in engineering, and especially when you work, you would come back to the theories represented by the feedback and control system, such as the steady state analysis and even the block diagram analysis. So here in your figure, you have here your input response, which is delta of t, which will undergo the system or plant H, and will have an output of y of t, which is also equal to h of t. So we have already understood how we can solve block diagram response. So here, we will now understand yung mga LTI systems natin. So it is stated here that time response analysis states that when the energy state of any system is disturbed and the disturbances occur at input, output, or both ends, then it takes some time to change from one state to another state. This time that is required to change from one state to another state, please take note, it is called the transient time. Okay, so the value of the current and voltage during this period is called transient response. So the errors or the noises that we have discussed as a component of the block diagram can occur at any point. So commonly, in a given problem, nilalagay siya sa summing junction natin. Okay, so yun yung mga outside factors na tinitake into consideration natin, wherein we cannot fully assume that the system is in the ideal condition. Meron tayong disturbance na nagaganap. So hindi porket na siya ay hindi kailangan ng system is hindi natin siya ito-take into consideration. So those disturbances and noises, even they are unwanted, you need to take into consideration their value or their signal value. So kung nasa summing junction siya at even siya ay in the form of noise, you need to consider that. Okay, idadagdag mo siya. Okay, so the value of current and voltage during that very period is called the transient response. Okay, so here we have the time response analysis. Depending upon the parameters of the system, the transient may have oscillations which may be either sustained or decaying in nature. So dalawa lang yung ating value. So we all know that when the graph is exponential or exponential, it is continuous, di ba? Exponentially decaying or exponentially growing. So pag sinabi natin decaying, so pababa siya, no, imbis na pataas. So this time response of a control system is divided into two parts. So we have here the transient response analysis, which deals with the nature of the response systems when subjected to an input. And number two is steady state analysis, wherein it deals with the estimation of the magnitude of steady state error between input and output. Okay, so when we say transient response analysis, is what would be your response, okay, when you are when the input is involved, okay. So kailangan meron ka ng involved or nalagyan na ng input yung system mo. What would be the response of your system? Now the difference with steady state is you need to consider also the output, okay. So you understand that there is an input and output to your system, and you estimate, okay, estimate the value of that using steady state analysis. Okay, so there are different types of standard test signals. So the various inputs or disturbances affecting the performance of a system are mathematically represented as a standard test signal. So number one, it can be considered as a step signal or the sudden input. Number two, the ramp signal, wherein it is the velocity type of input. Parabolic signal, type of acceleration input, wherein your input measures acceleration by the initial and the final. And lastly, impulse signals or the sudden shock. Okay, so these are the type of standard test signals used to understand LTI system. So you have here a representation using a diagram. Okay, so you have here the step, the ramp, the parabolic, and the impulse signal. So you have number one, the input natin for the unit impulse response. So as you can see, the delta going to WT. So meron tayong graph representing that kind of signal for the impulse response. So as you can see, at some point in time, okay, there is a sudden exponential growth of your graph, then saka siya magde-decay. Okay, so kaya siya tinatawag na sudden shock, no? So at some point, mamimit niya yung highest or yung pinaka-maximum voltage that it can have, then saka siya magde-decay going back to zero. Okay, so para lang siyang na-shock talaga. Then next is yung unit step response. Okay, wherein the value is just a transformation of your input signal from zero going to a specific value, no? Hindi siya nag-i-increase unlike yung ating input response, no? So ating input response is a continuous growth, no? Hindi siya direct. Sabihin, some point in time that is 0.1, 0.2, 0.3, 0.4 hanggang maging, let's say, number 1, no? 0.9 and 1. Yung ating unit step response, that is an automatic or that is a step agad doon sa ating system wherein from 0 going back to 1, then 1 going to 2, going to 3. No? So, yan po ay direct. Then, saka po siya mag-stabilize. Then, next is yung ating unit ramp response. Okay, wherein the nature of ramp natin is by its name or by its name, ramp talaga siya where it will be continuously or exponentially growing in value. Then lastly is yung unit parabolic response po natin wherein the input can start from a minimal value but it will increase exponentially over time with respect to its output. Okay, so that is the different type of standard test signals that you will or you can encounter in LTI system. Okay. So we have here the first order system. So here you have an example. Okay, so for unit step response, so meron ka ditong feedback circuit. So wherein your circuit is composed of C of S over R of S, which is equal to 1 over TS plus 1. So yung ating input is yung R of S and yung output natin yung C of S, but you have to consider the value of E of S. So yung ating system is 1 over TS. Then since meron nga po tayong feedback, so meron tayong plus 1. Okay? So the input RT, which is equal to your unit step, is equal to UT, which is equal to 1. The Laplace transform of RS is equal to Laplace transform of function UT, which is equal to 1 over S. Okay, so upon solving that using unit step response, you need to consider the transfer function C of S over R of S being multiplied to the Laplace transform value of the unit step. Ibig sabihin, i-consider mo both yung ating input over, yung output over yung input natin or the block diagram transfer function natin and the Laplace transform function. So, hindi mo siya pwedeng hindi i-consider. So, therefore, your C of S is equal to 1 over Ts plus 1 multiplied to the value of your Laplace transform, which is 1 over S. So that is 1 over S minus T over ST plus 1. Okay, so your C of T is equal to 1 minus E raised to the value negative T over T, wherein your T could not be, your T is greater than or equal to 0. So therefore, upon substituting the value, you can have E function T is equal to RT minus CT, which is equal to E raised to negative T over T, wherein your E at infinity is equal to 0. So your C of T natin is equal to 1 minus E raised to negative 1. So that is 0.632. Okay, so the value of your C or the derivative of C with function T over the with respect to time, given that T is equal to 0 is equal to 1 over T raised to the exponent E raised to negative T over T, wherein again, your T is equal to 0, so that is 1 over T. Okay, so that is your unit step response. So do not forget, when solving unit step response, you need to consider also the Laplace transform of your unit step function. Okay, hindi ka lang basta nagsasolve ng block diagram mo dito. You need also to consider the block diagram function and the Laplace transform R of S. So here, meron ulit tayo example, but this is now an example for unit ramp response. So you have here an input and an output of C of S over R of S, which is equal to 1 over Ts plus 1. So ganun pa din, yung ating block diagram. Meron tayong R of S, C of S, then meron tayong E of S. But now, our unit ramp input is equal to T. So kung kukunin natin yung Laplace transform R of S, so hindi ko na siya isa-solve for you. Ang ating Laplace transform of S, which is L of T, is equal to equal siya sa 1 over S squared. So the unit ramp response upon solving is C of S is equal to 1 over Ts plus 1 multiplied to the Laplace transform function. Okay? So, ganun pa din ang gagawin nyo. No? Unlike nung kanina, wherein ang ating Laplace transform is iba. Ngayon kasi is T na yung unit response natin. So, multiply nyo sila. 1 over Ts plus 1 multiplied to 1 over S squared, which it will give you the answer 1 over S squared minus T over S plus T squared over Ts plus 1. So C of T is equal to T minus T plus Te raised to negative T over T, wherein your T is any number greater than 0 or equal to 0. Okay, so if you will plot or if you will draw your graph here with respect to your input and your output, so as you can see there, the comparison between your ideal input and ideal output. So the difference between them, if you will measure that, that is your steady state error. Okay, so for the first order system naman ng ating impulse response, so meron naman tayo ditong 1 over Ts plus 1. So for any value of your block diagram, so the input RT or the unit impulse, so may given tayong simple unit response wherein ang Laplace transform natin would be just 1. So dahil dyan, dahil 1 lang naman yung value natin, our C of S can be the Laplace transform function of your 1 over st plus 1, which will give you the ct t raised to negative t over t, wherein t is any value greater than 0. So as you can see, ang ating magiging impulse response there is, or the graph there is 1 over t e raised to negative t over t, wherein it is exponentially decaying over the specific period t. Okay, so that is the graph or the equivalent graph of your first order system when it comes to your unit impulse function. So summary of our first order systems. So your input response and the output response has the table given here. Okay, so yung kanina is in derivation lang yon. So if you need to come up with a function of your input and output using impulse response system, kailangan familiar ka with this table. So yung ating ramp function sa input will have RT is equal to T, wherein yung T natin is any number greater than 0. So ito yung magiging output function niya. And yung step and impulse will also be the same. So how can we recognize if a system is in first order? So a system is in first order when you plot the log or the logarithm of the absolute function c of t minus the infinite function of c. And if the plot is linear, then the system is in first order. Okay, so a reference natin ulit will be the Control Systems Engineering 6th edition. So meron din na tong 7th edition by Norman S. Knights. Okay, so that would be all for your week 7 discussion of feedback and control systems.